So for the fourth lecture in project decision rules, we want to compare the NPV and IRR rule and see if they ever have conflicts on selecting the best project for a firm. So the goals here, we're going to sort of review the strengths and weaknesses of the two rules, and then we're going to run through a few scenarios where the NPV and IRR rule may conflict. This is actually a fairly lengthy unit here. So you may want to listen to this a few times and of course work all the assigned homework problems to make sure you understand this concept. But look at the NPV rule. It uses all the cash flows of the project. Remember, that's a weakness of the payback rule, right? Because the payback ignored what happens post-payback. NPV does not do that. It uses every cash flow the project generates. Perhaps most importantly, it discounts all the cash flows at the project cost of capital. This is the average return sought by our investors, whether it be bondholder or stockholder. But more importantly, NPV captures any extra gain we generate for the shareholders. Because recall, the cost of capital represents the return we need for the average investor, so anything beyond that, the shareholders will own. Now, the one reinvestment assumption is that we assume all the cash flows generated by the project are reinvested by the firm at the cost of capital. Now, the problem with the NPV rule is it can be difficult to explain. Think in your head for a minute, how would you explain an NPV of, say, 7 cents to someone? It doesn't look too impressive, but yet it is. It means you've returned the required return the investors want, and you have extra left over. But for those who have not been to business school or had an intro finance course, that's sometimes hard to get or understand. Second thing is, notice that NPV is sensitive to your cost of capital. I've said in earlier units here that measuring the cost of capital can be difficult. So NPV is a little sensitive, so you should always calculate NPV for slight variations with your discount rate just to see how robust or sensitive it is to the change. When we look at the IRR rule, it's the easiest rule to communicate to others because we're talking about percentages, you're talking about a profit rate, and we're comparing it to the financing cost. It's easy to relate the results. It shows a profit rate. The one problem it has is it doesn't use the shareholder cost of capital, which we'll get to in a minute, but in a way it's a strength because you don't have to have an accurate measure for the cost of capital, which takes one difficulty away of doing project finance. Our weaknesses, of course, it doesn't use investor cost of capital. It has trouble sometimes distinguishing if you're the borrower or lender. We'll get into that in a little bit. You may have multiple internal rates of return. And then the key one here, which is what we'll discuss a lot, is the problems with mutually exclusive investments. It can conflict with the NPV rule. That's a problem. And mainly for three reasons: the scale of the project, multiple IRRs, or the timing of the cash flows. We're going to focus our time on mutually exclusive investments. Now, some of the other issues with internal rate of return are for more advanced situations. Here we want to focus on what you may see in real life, which is mutually exclusive projects, where you have to select the best choice, the best project, so one or the other. And we want to look at cases or potential situations where NPV and IRR disagree with one another. Let's look at some examples. First one is scale. So we have Project A and Project B, and they're mutually exclusive, so we have to pick the best one. And the cost of capital for the firm is 10%. So if I look at Project A, it's just a simple one-year project. So if I discount the year one cash flow of $2 by 10% and subtract the initial investment, I get an NPV of 0.82. If I calculate the IRR, clearly it's doubled, right? We invest one and get two back, so the IRR is 100%. Project B has a larger scale. We invest 10, but we get 15 back. When you discount $15 one period and subtract off the initial investment of 10, we get an NPV of 3.64. However, you've only gained half as much. The IRR is just 50%. So suppose I'm applying my two rules here. clearly project B has the highest NPV, but clearly project A has the highest IRR. Which rule do you go with? Well, our hard and fast rule here is we always go with the NPV rule. And I know it has some cons of being difficult to understand, but at the end of the day, it reflects the shareholder desired return, and that trumps everything else. A second problem we can run into is when a project has more than one IRR. And when that happens, we have a lot of trouble interpreting the result. This occurs when you basically have two sign changes. I know that's kind of hard to understand, definitely hard for me to explain, but look at the example on your screen now. We start out with our typical year zero investment, and for most projects, years 1, 2, and 3 are all positive cash flows, so 1 IRR. But here, year 2, it's negative. So we actually have 2 investments on this project. So every time we have negatives in our cash flows, we're going to have an IRR. So here, if you calculate IRR, you would get 7.19% and 403% for the second one. Interpreting this is the problem. Calculating this is an even bigger problem because your financial calculator will just find the first IRR. It would not find the second IRR. So our best rule of thumb again here, use NPV. Finally, timing of the cash flows. So when you get your cash can determine the IRR and NPV of the project. So we have 2 projects, A and B, and here are their respective cash flows. So we're going to solve for each project's IRR, and then we're going to build an NPV profile. This is kind of an advanced topic for this summer, but I just want you to understand what can happen and why you have to be careful. So let's do the analysis. I worked out a solution here using Excel. You could do this in a financial calculator by simply plugging in the cash flows to the project and then go to your NPV button and plug in different interest rates and calculate the NPV each time. There's no rhyme or reason to why I go every 4% here on my tables. I just wanted to go far enough where we go from a positive NPV to a negative NPV. So look at our 2 projects. And mainly let's focus on the results. So if you look at 0%, A has a higher NPV. At 4%, A still does. At 8%, A still has a higher NPV, but barely. Finally, at 12%, it flips from A to B. B has a higher NPV. So clearly, if I use the NPV rule, it's going to depend on the cost of capital. That's the key thing here. Depends on my cost of capital what decision I would make. Look at the IRR of each project. Well, clearly, B has a higher internal rate of return. So using the IRR rule, it would be a hard and fast decision to take project B. So we have a conflict here. And the question is, which rule do we use, or how do we resolve this? Well, we're going to go with the NPV rule. And if we sort of summarize our profile, you can tell that project A dominates early on for low cost of capital. Then there's a crossover point there, somewhere between 8 and 10%. Looks like really between 9 and 10%, where we switch from A to B. And then B dominates A all the way up until its internal rate of return. Hit pause if you need to look at this for a few minutes. Well, I'm going to sort of give you this number. For the graph, the 2 NPVs are equal and the cost of capital equals 9.67%. So let's go back to this graph for a minute. I know I hate doing this, but let's do it. So from 0% all the way up to 9.67, I'm going to put the cursor where they intersect here. Project A has a higher NPV than Project B. So my decision rule would be take Project A from 0% all the way up to 9.67%. And after that point, we switch and we go to Project B. So from 9.67% on, we would take B over A. Notice I'm sort of tracing a line here. And we keep taking B until we hit its internal rate of return. You know, we never take a project just to take it. It would have to have a positive NPV. So review this slide again, hit pause perhaps, make sure you understand the rationale. So to summarize, always take the NPV decision rule as our preferred rule because it represents our investor. So summarizing our graph, we would take project A from 0% up to 9.67 because it has a higher NPV. We would take project B from 9.67 all the way up to 15.66. Well, 15.66 is the internal rate of return for project B, or in other words, where the NPV equals 0. We never take a negative NPV. So this concludes this unit. Please work some of the homework problems. And really the key is just understanding why NPV and IRR can conflict and why we want to use NPV. What I'm looking for in a testing environment is I want you to be able to calculate some cash flows, get me an NPV and IRR, and understand why you're doing it.